Okay, so this video is going to be on the Born-Haber cycles for the thermodynamics. So this is a topic I just recommend you just practice, to be honest, but yeah, here we go. So first we do the enthalpy of formation. However, we need to break the compound into its elements, so we use the negative value for this, and this is because obviously we want the dissociation, not the formation. Then we need to do the enthalpy of atomization, and we need to have our reactants in their gaseous form. What we then do is we do the enthalpy of ionization. We need to ionize what will be our positive ion. However, in this case, magnesium needs to have a 2+ charge, so we undergo a second ionization. Then, now we've got our magnesium all sorted, we need to look at our chlorine. So now we do another enthalpy of atomization, and that's because we need to look at all our reactants and they need to all be in their gaseous forms. Then, once we have the top row, we need to think, okay, now what do we need to do? So we do the enthalpy of electron affinity. We look at our desired compound, Cl, and this needs to have a -1 charge. We have 2 moles of Cl, so we're going to do this first electron affinity twice. Finally then, we've got our Mg2+ and our 2Cl-, and now we just do our lattice formation, and we can form our compounds using the ions. So that's basically the Born-Haber cycle for this. Just something to note, we have to add electrons whenever we do ionization, because everything has to be balanced, and also upward arrows are endothermic, downward arrows are exothermic. The value for the bond dissociation enthalpy is 2 times the atomization enthalpy for diatomic elements. So, for example, if we have chlorine being turned into chloride, well, 2Cl, that shouldn't have a minus. This is the bond dissociation enthalpy, and will have a value of around, say, 242, whereas the atomization value, because we're forming 1 mole of atoms, it will have half of this value, because everything is being halved, so we'll only have a value of, say, well, half of 241, 120.5. So finally, a second electron affinity will have a positive value and an upwards arrow, and this because energy is needed to add an extra electron to counter the repulsive forces. It's better to just go through this with examples from exams, to be fair.